Good morning, everybody. Today we are looking at 4.2 inferences for two population means. Here we're going to assume that their standard deviations are equal. Now, when we talk about assuming that standard deviations are equal, we'll see later on in our first example, we don't mean exactly equal. We do mean approximately equal. As long as they're relatively close, then we can proceed with this hypothesis test that we're developing here today. You can see first here we have the z-score that we looked at yesterday, and then we're going to further simplify that. We're going to replace the sigma sub 1 and sigma sub 2 with their common value sigma, and then we can apply algebra, factor out the sigma, and we'll generate this new denominator where we have sigma times the square root of 1 over n sub 1 plus 1 over n sub 2. However, the thing is, sigma is not known. We have to compute some value for sigma. And so what we're going to end up doing is generating the sample variance for each one of the populations as a whole. And you can see here, this is the sample variance of the populations that we'll be looking at. And we can simplify that by taking the square root of both sides. And we end up with this pooled statistic is what it's called. This is the standard deviation, or the pooled standard deviation for the two populations that we're looking at. And then so we can rewrite the test statistic that we started out with in this form here. Don't get hung up on all the algebra that we get here. Just make sure that you understand how to use these formulas, and we're going to discuss that here in this first little introduction. So what we're calling this is a t statistic, so we will use the t table for today's notes. And you're going to take the this is the equation here to find the value for t, for your test statistic for your hypothesis test. So it's going to include the mean of the sample of the first population minus the mean of the sample of the second population, minus the difference between the means of the populations as a whole, not the samples, divided by that pooled standard deviation statistic that we calculated or showed how to calculate a second ago, times the square root of 1 over n sub 1 plus 1 over n sub 2. And we have degrees of freedom are going to be equal to the two sample sizes added together minus 2. And that'll give you the degrees of freedom to look up the values in the t-table. So we developed this procedure. This is something that we've seen several times over. This one is the pooled t-test. So we, like I said, we'll be using the t-table for our references to come up with our values. And we want to look first at the assumptions that we want to come up with. First, the assumption is that we do have simple random samples. The second assumption is that they are independent samples. The third assumption is that we have normal populations or relatively large samples. And then the fourth assumption is that the population standard deviations are approximately equal. The hypothesis test, just like what we've been doing here, the null hypothesis is that the population means are equal to one another. Then we have the three alternative hypotheses. We have the two-tailed test where the two are not equal, the left-tailed test, and then the right-tailed test. And then we also have a significance level. We've done this before. The difference here is the step 3 where we have to compute the value of the test statistic. There's a little bit more to it that we have to look at. So we can see here's how we compute the value of the test statistic. And this is how we compute the value of the pooled standard deviation. So we're going to have two kind of not complex calculations, but they are calculations that when you enter them in your calculator on your computer, you do have to be careful how you enter them to ensure that you do get the correct answer. Critical value approach and p-value approach is still going to be exactly the same as what we've looked at in the past. So we will start with example 1. Example 1 refers back to a problem we looked at yesterday with the salaries of the faculty members at private and public institutions. We were comparing the mean of the samples to make an inference about the mean of the populations as a whole. So let's first go back and look at the first 4 assumptions. Relative to example 1, we want to check the 4 assumptions. So it does say in the example that the samples are given as simple random samples, so the first assumption is met. It's also indicated that they are independent samples, so assumption 2 is met. And then assumption 3, we're going to look at the large sample aspect of it. Both samples are large because they are 35 and 30 respectively. So now we need to come up with a way to check to make sure assumption 4 is met. So we're talking about equal population standard deviations. So what I've done is I've gone ahead and I've entered all these data into a Google Sheet. First column is the private institution, the second column is the public institution, and we need to compute the means and the standard deviations for the samples on both of these. So in column A for the mean, remember you just type in equals average. I'm going to put in parentheses, and my values run from A to 36. So I have my mean value for the sample is 98.19. That's for the private institutions. Then I want to do the standard deviation. So that's equals STD EV. And then we do a dot S to indicate that this is a sample standard deviation. And again, it's going to be A2 A36. And I get my sample standard deviation is 26.21. And I'm going to do the same thing for the public institutions. So we have average. In case it's B2, B31. And standard deviation. .95. So looking at the 2 standard deviations, we can see they're not exactly equal, but they are close. So we can say that these 2 are relatively equal, approximately equal, so we can go ahead and proceed with the testing procedure. And we're going to do that here. So the first thing we want to do is make a list of the values that we know. So for private institutions, we have that the mean for the private institutions was 98.19. We have the sample standard deviation for the private institutions is 26.21. And we also know that the number of samples or number of data points in the sample is 35. Then for the public institutions, we've done the same thing. We have the same values we need to analyze. We have the mean was 83.18. Sample standard deviation 23.95. And sample size 30. So our first step is to state our hypotheses. The null hypothesis is that the 2 population means are equal. The alternative hypothesis, we are looking to find if the population means differ. So we're looking at a 2-tailed test, which means we're using the not equal to symbol in our hypothesis test. So let me just make a note that is 2-tailed. And now we can compute our test statistic. So before we compute the test statistic, we do have to come up with that value for the pooled standard deviation. Remember, that's that S sub P, which is going to be equal to I'll write out the formula again. So that's the formula, and we're just going to substitute in all the values that we know. We know everything on there, so we have n sub 1 is 35. 1 is 26.21. Square that. 30. S sub 2 is 23.95. We will square that. And then when we type this in, what we get on our calculator is that this all is approximately equal to 25.19. So we have our value for S sub P. We can go ahead and now compute our test statistic, which is our value for T. And in this case, T is going to be X bar sub 1 minus X bar sub 2. That's the two sample means. T times the square root 1 over n sub 1 plus 1 over n sub 2, and we will just substitute in our values and simplify this. So our X bar for the first sample is 98.19 minus X bar for the second sample 83.18, and that's going to be our S sub P is 25.19. We calculated that in the previous step. 1 over 35 plus 30. And we simplify this, we get 2.395. So here is the value for our test statistic. That's our value for T that we want to look at. We also are going to apply the critical value and the p-value approach. So the first thing we'll look at is the critical value. And to do this, we first have to also find the degrees of freedom. Remember, the degrees of freedom for two populations is going to be the sum of the sample sizes. So it's 35 plus 30 minus 2, which will be 63. So we have degrees of freedom is equal to 63. We know that alpha is 0.05 because we're looking at a 95% confidence level. And since it's two-tailed, we want to find plus minus t sub alpha over 2 plus minus t alpha is 0.05. So that's going to be plus minus t sub 0.025. So when we refer back to the t table, degrees of freedom 63, so that's this row right here. T sub 0.025, we get 1.998. All right, and so then if we think about that as far as the normal curve goes, negative 1.998, remember it's a two-tailed, so we have to use both values, and positive 1.998. So anything to the right, positive 1.998, or anything to the left of negative 1.998 will fall in the rejection region. Our t value that we did compute was 2.395. So it does fall within the rejection region, so we will reject null hypothesis. Similarly, we can compute the p-value approach and do the exact same thing and hopefully come up with the same values. So again, the t statistic is 2.395. And we're looking at 63 degrees of freedom. So 2.395 falls between these two values. So 2.395 is between 0.025 and 0.01. So now we know where our p-value falls. And we want to compare that to a alpha value of 0.05. Well, because our p falls between these two values, it has to be certainly less than 0.05. And so therefore, because it's smaller than our significance level, we can once again reject the null hypothesis. Like I said before, we're not doing anything new as far as interpretation. It's just we have a new formula that we have to work with. So just please be careful as you enter these to make sure that you don't come up with any errors as you type these in. The confidence intervals, we're going to do the same thing here with confidence intervals. The endpoints for the confidence intervals can be found by the difference in the sample means plus or minus the value for t at alpha over 2 times the pooled significance standard deviation multiplied by the square root of 1 over n plus 1 plus 1 over n plus 2, or 1 over n sub 2 rather, and then you can make the interpretation. So we're going to see that here with example 2. Hopefully that will make sense to you when we go through the example. So for a 95% confidence interval, our alpha is 0.05. Go to that. Gives us an alpha of 0.05. We know that our degrees of freedom is equal to the sum of the population sizes, or sample sizes minus 2, which will be 63. And then we can also go back to the t table. We're looking for t sub alpha over 2, t sub 0.05 over 2. Now we already know the result here, but with degrees of freedom and t sub 0.025, again we do have 1.998. So there's our value for t sub alpha over 2 in our equation that we're going to use to find the confidence interval. So the confidence interval once again is x bar sub 1 minus x bar sub 2 plus or minus sub alpha over 2 times the pooled standard deviation. It's going to be over 1 n sub 1 plus 1 over n sub 2, and we just substitute in the values and we can come up with the confidence interval. So in this case we have 98.19 minus 3.18 plus or minus, we use that value we just computed, 1.998 times our pooled test statistic, which we found in the previous example. It was 25.19, so we won't go through and recalculate that. Type this in, what we end up with is 15.01 plus or minus 12.52. And when we do the addition and subtraction, we generate a confidence interval of 2.49 to 27.53. So that generates our confidence interval of $2,490 to $27,530. And as far as our interpretation goes, we can say that we are 95% confident that the difference between the mean salaries of faculty in private institutions and public institutions is somewhere between $2,490 and $27,530. Or another interpretation, or another way to look at that would be that we're 95% confident that the mean salary of faculty in private institutions exceeds that of faculty in public institutions, somewhere between $2,490 and $27,530. I know it's just two examples, and it's relatively easy, just making sure you're doing the correct substitutions. So for the homework, what I'd like for you guys to do is go through and do number 5, and let's just do 4 and 5 today. Okay, so do number 4 and number 5. Those will be due tomorrow, which will be Wednesday. And again, if you all have questions, please just let me know. Hope everybody's doing well. It's storming here, and just going to hang out in the house all day, I think. So everybody take care.